Okay, so we did two questions on average speed and average velocity. Now, let's try a similar question, similar to question number two. But this time, I would suggest you to pause the video and try to find the answer on your own. You can directly use the formula that is derived in question number two, or you can do it, try doing it on your own, the entire question on your own. That's up to you. But I would say don't follow the video as of now, pause it, and then resume once you have completed the question. Anyhow, I would be doing the question in the elaborate way so that all students can understand. You may skip that part and go to the answer where you just apply the formula. Okay. So, having said that, let's move on to the next question here. A body covers first one third of the distance with a velocity of 20 meter per second, the second one third with a velocity of 30, and the third with a velocity of 40. The average velocity nearly is. Okay. So, let's start solving this question. So, as I always suggest, make sure that you draw a diagram so that things becomes easy for the calculation. So the body is moving from A to B. Let us say it's C, it's D, and let us say the distance is 3x, and let us say this much distance is x. CD is also x and DB is also x. A to C is moving with velocity v1, C to D is moving with velocity v2, and D to B with velocity v3 in corresponding times t1, t2, and t3. Now, we know that average velocity is equal to the total displacement upon the total time. Now, what is the total displacement? It is 3x. What is the total time taken? It will be the sum of t1 plus t2 plus t3, right? Sum of t1, t2, and t3. Now, what would t1 be equal to? Now, I don't need to elaborate how to find the value of t1. Okay, let's not skip that part too. So for the motion along AC, what is displacement AC? AC will be, sorry, what is velocity? Average velocity V1 would be equal to AC upon T1, right? So what would be T1? T1 would be AC upon V1. What is AC? AC is X. So what is T1 is equal to X upon V1, right? So let us now put this value in the equation here. So T1 is basically X upon V1. What would be T2? Would be corresponding X upon V2. What would be T3? Would be X upon V3, right? In which case we can write further that if we write this 3x common and we take x common out from these two terms, what do we get? 1 by V1 plus 1 by V2 plus 1 by V3. Now, should I explain it more? Okay, let me just do that also. Let us not. Okay. Now, how much would this be equal to? This would be equal to 3x the whole upon x times. We know that the LCM is V1, V2, V3, right? And here it will be V2, V1 plus V2, V3 plus V1, V2. I don't need to derive this again. X and X will get cancelled. So what would be the final average velocity? It would be nothing but 3 times V1, V2, V3, the whole upon V1, V2 plus V2, V3 plus V3, V1. And those students who have a doubt here, I think I just made a small error here. V1, V2, V1, V2. This is not V1, V2. This is V1, V3. Sorry for that error. Okay. So now, in this case, this can further be written as, according to the question values here, 3 times 10 times. Okay, let me just cross check the values. It's 20, 30, and 40. Okay. So 3 times 20 times 40 times 20, 30 and 40. Okay, so 3 times 20 times 30 times 40, the whole upon 20 into 30 plus 30 into 40 plus 40 into 20. So this would be 3 times 12 is 6, 18, 18 fours are 72, right? So we have 72,000, the whole upon 3 into 2 is 6, 600 plus 4 threes are 12,200 plus 4 twos are 8, 800. So this will further be equal to 72,000 whole divided by 600 plus 1200 is 1800 plus 800 is 2600. So these two zeros will cancel off, and what we will be left is with 720 upon 26, which if we can cancel and divide both numerator and denominator by 2, what do we get? You will get this as 360 upon 13. So if you divide 360 by 13, you will get this as 13. 2 times is 26. So we're left with 100. And 13, 7 times is 91. So you get 7 times 91. So we left 990, which again would be 13 times 6. So it's approximately equal to 27.6, which we can round it as 28. So the correct option to this question would be option A.